the differentiation of ln of x is what? 1 out of x. So the differentiation of like ln of like x squared plus 2. The answer will be 1 out of x squared plus 2, then times the differentiation of this one here, which is 2x, like that, okay? So the final answer will be 2x out of x squared plus 2. So it means that the differentiation of x squared, ln of x squared plus y squared. This one here will be 1 out of, you copy the way it is, and then times. Then what the differentiation of this one? It is 2x. So the answer is 2x out of what? X squared plus what? Y. And that's okay.
Yeah.
Now, when you get this one here, when you get this part here, and you want to find the second differentiation, you got now, now we're going to have d over dx of 2x 2x out of x squared plus y squared, like that. So this one, you have, now we want to find the differentiation. Now in this case, we have the numerator, which is our u, this is our v. So we have to use what's called the quotient rule. The quotient rule. Quotient rule says that our uv minus uv, this is prime over v square, like that one there. So in this one here, we are going to have our u. Our u is 2x. What's our u prime? What the differentiation of 2x is 2. And then our v is what? It is our v was x squared plus y squared. So v prime. You know, we are treating y as a constant, okay? Y is a constant, so just be 2x. So the final answer will be our u prime is 2x. Our u prime is 2, actually is 2. Our v is x squared plus y squared minus our u is 2x. It was 2x. And our u v prime is 2x, like that, divided by x squared plus y squared. Then when you expand, this becomes 2x squared plus 2y squared minus 4x squared divided by whatever.
Are we going to square the denominator, the whole of the denominator?
Yeah, we square, yeah. So then you in this one, you're going to have y squared minus 2x squared, like that, over x squared plus y squared, then you square there. You see that one?
Yes.
So now let's go back to our question, but now I'm going to do it in a simple way. So now in this case, you're going to have our du dx will be equals to 1 out of x squared plus y squared times 2x, which would be what? 2x out of x squared plus what? Y squared. That's okay?
Yes.
We want to find also our du dy. So this one will be like 1 out of x squared plus y squared, then times, then differentiation of y squared is 2y. So the final answer will be 2y out of x squared plus y squared, like that. That's okay?
Yes.
But because we want to prove it's harmonic, so you have to find the second derivative, d squared u over dx squared. Now this is the one that we have done on the other page, this one here. So this one, you find the differentiation of what is on the top is 2. You copy the bottom the way it is. Then minus, you write top the way it is. The bottom differentiation, the bottom is 2x, like that, divided by x squared plus y squared, then you square. So the final answer will be what? You can see when you expand, you get 2y squared minus 2x squared divided by what? X squared plus y squared, then you square. That's okay.
Yes, yes. Now it's
So
okay.
then you find the second, we find du squared over dy squared. So now we are, what you are differentiating this one here, this. You see that one?
Yes.
Okay. So what the differentiation of 2y is 2, then you copy the bottom the way it is, x squared plus y squared minus, you copy the top of the way it is y, then you have a 2y like that. Then out of what? X squared plus y squared, then you square. So this one becomes, you can see when you expand this one, it become what? Become 2x squared minus 2y squared out of x squared plus y squared, then you square. And we see that for a function to be harmonic, then it should fulfill what's called the Laplace equation. Do you remember the Laplace equation?
Yes.
D squared u over dx squared plus d squared u over dy squared is equals to 0.
0.
So now in this case, you're going to copy the here. That is 2y squared minus 2x squared divided by x squared plus y squared. We square again plus 2x squared minus 2y squared out of x squared plus y squared square there. You can see clearly that these cancels, let me use another pen. These cancel this one, yes, no, that one.
Yes. Yes.
And this one cancel this one. So we're going to have 0 over and sorry number here. And the other is 0
Yes.
still. Yeah.
Yes. It's 0.
To me that the function is harmonic. So the
Harmonic.
function is harmonic. Now we want to go a step ahead and then find what you call the harmonic conjugate of this one
Conjugate.
here. But you're going to use only this part here. This part. You're going to use this one and this one here. So let me copy them on a clear page. Is that this page also okay?
Yes, it's okay.
Okay, let me go and put it in a clear page. We are saying that du over dx, for it to be analytic, should be what? dv over dy.
Y.
And ours was 2x out of x squared plus y squared. We're going to have this part here. So we cross multiply, we can get our dv is equal to 2x out of x squared plus y squared, then dy. Then integration of this one here. And I told you that integration of this one is something like this one here. Integration of fx prime out of fx dx, answer is what? ln of what? fx, like that.
FX.
Plus c. And you can see clearly that if we find the differentiation of the bottom, we get 2x, which is just like the one on the top, okay? To mean that our v is equal to ln of x squared plus y squared plus like gx, something like that. And then you also know that our du over dy should be equals minus dv over dx. And ours was minus 2, was it minus 2y? Yes. Let me go back actually. This was minus. This was this one here minus 2y. Okay. That one there. Okay. It was positive. So equals to 2y out of, it was positive actually, 2y, then you have x squared plus y squared. So you're going to check this part here. So you're going to have our dv is equal to minus 2y out of x squared plus y squared, then dx, integration of this one here. So v equals to, this one here is still the same, minus, then you go to have what? ln of x squared, or was it dx? dv equals to
X squared plus y squared.
let me see.
What do you do with the negative?
No, let me see. Well, this one here is this one you cross multiply and get dx here. Dx. Oh, is this let me see for harmonic whether is this one okay? du dy is equal minus dv dx. Let me check. Oh yeah. Now this one is the one. There's then yesterday there's a mistake that we did here. Then so this was okay. It was like that. Yeah. There's a small mistake that we did here. So that you can have this is what? Our dv over dx is equal to minus 2y out of x squared plus what? Y squared, like that. So then in this case here, we are going to have our dv is equals to minus 2y out of x squared plus y squared dx. Integration of this one here. So integrating in terms of x. And the integration of x is not what, it's not what on the top. Integrating on this, differential of this one is not what on the top there. This is just like a number. So what you do, you can take we can take this one on the top. Can have our v equals to integration of minus 2y, then ln of what? X squared minus, no. Let me see. dv dx dy du equals minus dv dx dv dx. So dv is equals to minus 2y out of x squared plus y squared, then dx. Integration here. So dv v equals to we got yesterday we got a number which is what? Minus what? Minus ln of x squared plus y squared plus like hx, something like that. But I have to check this one whether it's true, because now v, of course v should have this part here. This part is okay. This part is okay. It must have ln of x squared plus y squared. And then we say that this part here is minus ln of x squared plus y squared. But I have to check this part whether it can work. I have to check that one. I'll check that one, then I'll tell you the last part tomorrow. So that was like that one, but you can see those steps the way you have done them. These are the steps here. This part is okay.
Yes.
And then the last part we have done it there. The last part, the last part is the one that was a problem, but I checked why is why I'm going to do it backwards. I see whether it's going to work. Then I tell you whether it's right.
Okay.
And then there was
Okay.
the other question was what? The poles one. Number 5.
Yes.
Number 5, was it okay or you do it again? Number 5 was, let me copy it somewhere. It was fx so we want to find A. We want to find the residues and the poles. Residues and the poles.
Related to our second break here on Citizen Weekend. We'll be back with much more. Stay with us.
So it was like this. A fx fz equals to 4z squared minus 6z plus 1 out of z squared, and you have z minus 2 like that. Then you see that z squared, now this one you can see that z equals to 0. We're going to have z squared z minus 2 is equal to 0. So z equals to 0 and z equals to what? To 2. So z equals 0, we say that it's a pole of order 2. And this one here is a symbol pole of order 1. Order 1 like that. Now, and we said that when you're doing the symbol poles, it's very easy. You just write the fz is equal to the limit of z approaches the 2, and then you're going to have the z minus 2 there. Then fx, our fx is 4z squared minus 6z plus 1 divided by z squared. Then we have z minus what? 2. So you can see that in this one, it goes just to cancel out. This cancel out like that. And then you substitute with the 2. So you go to have 4, then you have 2 squared minus 6, 2 plus 1 divided by 2 squared. What do you get? 16 minus 12 plus 1 divided by what? By 4. What answer do you get? 5 or 4? No. Yeah, so this is our residue. Yeah. When z equals to 2, when you have the symbol poles, very easy. Very easy. Actually, I wrote you the formula for symbol poles. But when there's a pole of order something, there's a lot of work to be done. Like, do you remember the formula for when it's not a symbol pole? We wrote it. We said that the formula is our FA is equal to 1 out of n minus 1 factorial, then dn minus 1 out of dzn minus 1. Then you're going to have our z minus a times fz like that. Then dz like that. That's what the formula. So it means that in our case here, our n is 2. So we are going to have 1 out of 2 minus 1. Then factorial. Then dz, that is 2 minus 1 is 1 out of dz. 2 minus 1 is just like that. Then you're going to have z minus 0. Of course, there's a square there. Then times fz was 4z squared 4z squared minus 6z positive 1 divided by z squared, then z minus 2 like that. So that we can simplify this one here. This can cut this one here. And then after that, after this one here, this is what we're asking ourselves what are supposed to do. This part we can, we're going to have like, of course, 2 minus 1 factorial just 1. So there's nothing there. So be d over dz. Then you're going to have 4z squared minus 6z plus 1 divided by z minus 2. So you're going to use long division to divide this one here. So long division is 4z squared minus minus what? 6z positive 1. Then you do long division. We can also divide with the calculator. And this one even becomes a z minus 2 there. So this be 2z become 4. No, this must be 4z. 4z squared. This 2 here, this 2. So 4 times here is minus 8z. Then you minus. When you minus, what do you get? 2z plus 1. Then you're going to have plus 2. So it become, this is what? 2z minus 4. So this becomes 5 like that. So now you're going to have our d over dz is 4z plus 2 plus 5 out of what? Z minus 2. What then differentiation of 4z is 4. Differentiation of a constant is 0. Then plus 5 ln of z minus 2 like that. Now we are going to have our z equals to 0. Z equals to 0. This one here. So when you substitute 0 here, we're going to have this one going to have all 0 here. So the answer becomes 4 like that. So the remainder is 4. Actually, this one here, we have finished it. It should be like that. Now, here there is the issue of long division, this issue of partial fractions, and now there's also differentiation here. And you see that when it is not order 1, there's a lot of work to do because you have to remember that formula there. 1 divided by n minus 1 factorial, then d minus 1 there, then of that one there. And then you have to do all this process, and the residue here is 4.
Is z minus a is normally what? The
A is like when you, after factorizing everything, this is the last part that you're going to get, our A.
Or z minus a, okay.
And this, now this one, this the one that I wrote here, this one, you see, let me circle it.
Yes.
This one. See that
And the one inside the formula.
Yeah, this one.
And the one inside the formula, z minus a. Oh, okay.
That one there. Because z equals 0, yeah. That's why it is like, you see here, this part here, let me use another pen here. You see that this, you see this z minus 0, yeah.
Yes.
Minus 0 here. So this equals to 0 here, this one here. And
okay.
The one that is here, 0 here.
Wonder, yeah, I've seen it. I've seen it.
This 0 here. And this one is 0 here.
Okay.
Yeah.
It's okay.
And of course, I'm going to, I think this, I'm going to upload it on the YouTube so you can check. You can follow it again. Yeah.
Okay.
And follow it again, then
That's fine.
Yes. So, I can see we have like 6 minutes. Which other part of the question was this one?
As well as a navigator and driver.
Those are the ports, and integration was the integration. Let me see. Well, the same question, but we integrate this one here. Was that question with the great?
In the first African
Let me see, it was
all-female
what?
team to enter the rhino charge. This is what they'll encounter. 13 checkpoints scattered over approximately 100 square kilometers of rough terrain, all within a 10-hour period. No, first of all, but there is somehow to some extent people say that
Where is the question?
because they're controlling the machine. But as a team, we have to work together. They're together. Half the day before, we have to read map, and I have to trust that the map reading and points that the routes that we're mapping.
It was ends evaluate the integral of this one here. The integral of this one here. When z equals to 2.
Their presence in the competition inspires other women to venture into motorsport events.
The one that was given 2 marks. That was given 2 marks. 2.5. So both -2 and they're inside the circle. You have one of this one.
Is far bigger than history, though.
Partial fraction of this one. Yeah. Let me see one in breaking partial fraction again. Okay. So you see this one here. Now the part that you're not done is it is B and number 6. Number 6 and B. So the other part at least you can do something. No. Yeah.
Yes.
Because you're going to do something. So I'm going to check the Lowline series at night there. And then you're going to do it tomorrow. This the last part here. And also I check the B. Why is how to do that part there. So I think now we have the few comments, but we can still end our lesson there. So because I think tomorrow we are going to only to take the Lowland series, only that part, and then we can go back to the syllabus. Or if you have more questions, you can still ask. When we see that part is next week.
Yeah, on Saturday next week.
On Saturday, yeah. So there's those questions for like, can you go and check the question on finding the square root power of complex numbers, square root of complex numbers? The one that you approved, that like cos 4 theta equals that one, you try to prove that one, because those are some simple questions that they'll always be in your exams, and you can get them. And then even if you don't get the other difficult question, at least you can get your 45 marks, and then you cannot get an E. Yeah, but those who want to do well, then you can revise all the other parts. Yeah. So then let's end from there. Let's meet tomorrow to do the Lowland series and the few questions that the one you need to ask.
Okay. Okay. Thank you so much.
Welcome.